hot summer days, we see roadside sugarcane juice sellers keep bagasse, which is a kind of waste and can cause environmental pollution if not processed further. So, we aim to recycle and reuse roadside heaped sugarcane bagasse to extract natural fiber from bagasse if there is any by chemical treatment, make paper by chemically treated bagasse, and make biodegradable carry bags from fiber or paper at low cost as a replacement of thin plastic carry bags which are non-biodegradable, covered into toxic particles and enter into the food chain of animals. So, in order to save our ecosystem, we decided to make biodegradable carry bags. Now let us come to the working procedure. First, we did a survey. Our survey results told us that sugarcane is a grass. The bark and the internal core are separated. On crushing the internal core mechanically, a soft, pulpy, fibrous material known as bagasse is obtained. Bagasse is a lignocellulosic material containing lignin, hemicellulose and cellulose. We will focus on cellulose only at this stage. Cellulose has a formula C6H10O5-N, where N varies from 300 to 3000. It is a homopolysaccharide and a linear biopolymer of beta-D-glucose units linked to each other by beta-1,4-glycosidic linkage. One long chain links to another long chain with hydrogen bonds forming a bundle of fibers. This linear arrangement helps to form cellulose threads. Now let us come to the chemical pre-treatment. At first, the bagasse was soaked in ethanol and dried to remove impurities. Then it was treated in hot water and dried. For fiber extraction, we used both acid and alkali. For alkali treatment, we divided the bagasse into 3 equal parts and boiled them in 10% NaOH for 30 minutes, 1 hour and 2 hours to obtain various kinds of fiber. During boiling, hydrogen bonds between lignin, cellulose and hemicellulose weakens. Ester bonds and other bonds between them break down due to sodium hydroxide and thus solubilization occurs. Here, L represents lignin. Ester linkage between lignin and cellulose is hydrolyzed and cellulose chains are formed. On filtration, we receive thin, long, brown fiber as residue and a dark colored liquid as filtrate. Residue is washed, neutralized and bleached with hydrogen peroxide, after which the residue turns whitish in color and then is left for drying. When we repeat this process with 10% H2SO4 with boiling time 1 hour, no such long fibrous material is obtained. Thus, acid treatment is kept over as a future plan. Now, let us come to the fiber section. We make twines of 10 fibers each for each sample. Then, the twine's mass was divided by its length to calculate linear density, which is the only parameter to measure fineness of fiber. For yarn making, we can either do them in Z-twist or S-twist. We took 2 Z-twisted single yarns and twisted them in S pattern to form a 2-ply yarn. The yarn's tenacity, which is breaking load by linear density, was calculated. To observe the breaking load of twines, we made this equipment. Now let us come to the paper making process. For the first